as a math teacher, the most common question I get from students is, when am I going to use this information? And sometimes I can give an immediate answer, and other times it's more like you have to wait and see because mathematics, it builds over time, and so we need these skills to build before we can actually get to an application. So um, fortunately, with quadratic equations, we have some immediate applications, but also speaking for me and your future math teachers, if we have to say the answer of like, well, you need to get to this, right? And you might not see that in your journey, that's okay too, and we appreciate your patience with it. So, first example though, that we're going to see with quadratic equations is kind of an artificial example. So we have two numbers, right? Their product is 168. So these two numbers are x and y. And so if we think about that, x times y is equal to 168. We could get lucky and guess them. Okay, but we want to be clever if we can. We want to find them. We want to find them using other methods and be a little bit clever in doing so. So we know that these are consecutive even integers, right? So what does that mean? So if I think about like two numbers, right? So x and y, right? So if x is this number, right? And then there's another number, that would be odd, right? And then the next number here would be y, right? Well, isn't it the same as saying like y is equal to x and then I skip two numbers, so if I do y is equal to x plus 2, yeah? So then if I do that, x times, and then this is x plus 2 is equal to 168, then, oh, this is a quadratic equation, I think. So if I distribute the x, I get x squared plus 2x is equal to 168. Okay, I subtract that over and I get myself a quadratic equation, right? And I can solve this using a variety of methods, okay? Completely up to you what methods you want to use. I think I like factoring. So I'm going to do x. Let's see, I need a negative 168. So let's see, they need to give me, so this needs to be x, and x is equal to 0. I'm going to just try guess and check here. They're opposite signs, it looks like, right? And then guessing and checking, this took me a moment off screen. I got, this would have to be plus 14 and minus 12. Okay, so then solving each one of these independently, x plus 14 is equal to 0, and x minus 12 is equal to 0. So then x is equal to negative 14, or x is equal to 12, right? And so here, we would just need to double check. So if x is 12, that implies that y is 14. That one ends up working, right? If x is negative 14, then that implies that if I add 2 to that, y is negative 12, right? And so they are consecutive even integers, and they do multiply to give 168. So this one ends up working as well. Okay, so you actually get two answers, whereas via guess and check, you actually only find one. Okay, so I should say the two numbers are either 12 and 14 or negative 14 and negative 12. Okay, and I'm writing this out in a sentence because when we are given a context, we should always respond in that context. Okay, so again, this is kind of a superficial example, but it still hits the point of showing that there's an application to everything. Okay, and then looking at the next stuff, the next biggest area where we can see quadratic equations pop up is in the context of geometry. Before we get there, though, a little bit of review, right? So when we're thinking about a triangle, right? If we want to find the area of a triangle, the area is, we know, maybe 1/2 base times height, right? So this here would be the base of the triangle, and then the height would be the altitude. Okay, height and altitude end up being the same thing. Okay, area of a rectangle. When we think about a rectangle, we know some of its geometric properties. One is that it has 4 right angles, and then that the opposite sides are the same length, they are congruent. And so usually we call, one side the length and the other side the width, and we say that the area is length times width. And lastly, the Pythagorean theorem, this is also super helpful. This comes as a result of right triangle trigonometry, or connected to right triangle trigonometry, but also area of a rectangle. So if we call this, the base and the height, or typically in these contexts, you call this A, B, and then the longest side of the triangle is called the hypotenuse, that's C. We can say that C squared is the same as A squared plus B squared. Okay, just a very quick review of those formulas. Okay, and so the example here that's connected to it is talking about a rectangular field. So I need a picture. I see this stuff. It's a lot of words. I need to see this stuff in a picture form. So opposite, okay, we have a rectangular field. Okay. The distance between opposite corners of a rectangular field. Okay, so distance between opposite corners. So this would be this. That would be this distance D. Okay, so D is 4 more than the width of the field. Okay, I don't know which one's the width. Let's do this as the width, and this will be the length. Okay, and then it says the length of the field is 2 times the width. Okay, I maybe chose correctly. Okay, find the distance between the opposite corners and the area of the field. Okay, well, area of the field, that one might be an easier question, but let's kind of tackle these in order. Okay, so distance here. Okay, well, isn't that just the Pythagorean theorem, right? So distance squared is length squared plus width squared. Okay, and so then I look at this thing and substitute in what I know. So distance is 4 plus width squared. Length is 2 width squared plus width squared. Okay. So then, let's see. How do I do this? Oh, yeah, we have to write this out. We have to FOIL this out, right? 4 plus W times 4 plus W, okay, is equal to, this would be 4W squared. This one I can distribute because I have multiplication between, plus W squared. Okay, so I have 5W squared on the right-hand side. This, if I FOIL it out, I get W squared plus 8W plus 16. Okay, and now this is almost a quadratic equation. I'm going to move things to be on the same side, so I get negative 4W squared plus 8W plus 16 is equal to 0. Okay, factor out the 4, and maybe the negative 4. Why don't we do that? Yeah, let's do negative 4. W squared minus 2W minus 8, or minus 4, I'm sorry, minus 4 equals 0. Okay, and now I have to solve this thing, and I think there's no good way to factor that, if I'm thinking correctly in my head. And so then I need to solve it using the Pythagorean theorem. Oh, yay. So W equals negative B plus or minus square. Okay, I'm not going to sing it. But I do square root of B, which is negative 2. So B squared minus 4 times A, which is 1. I'm looking just inside here at this equation, times C, so that's minus 4, all over 2 times 1. Okay, so I get 2 plus and minus, square root 4, and let's say that'd be plus 16 over 2. So I get 2 plus and minus square root of 20 over 2. And so then, let's see, that would be, if I simplify 20, 20 is 4 times 5, so that would be 2 plus and minus 2 square root 5 over 2, also known as dividing everything by 2, reduces to 1 plus or minus square root 5. Okay, and now the only thing is that if I do 1 minus square root of 5, that gives me a negative number. So I'm going to use only 1 plus square root of 5 in order to make this thing work out. Okay, so then this means that length is 2 times this. Okay, and also distance, the diagonal distance d would be 4 plus that, right? So it would give us 5 plus 5, square root of 5. Okay, so that is one answer, and then I also need the area is length times width, and this is incredibly ugly because we have 1 plus square root of 5 times 2 times 1 plus square root of 5. And I'm going to leave it like that because it's kind of ugly. Okay, it's not a pretty expression. I could find it, I'm just not going to find it in this video. Okay, so then I'm just going to say the distance between opposite bases or opposite corners is 5 plus square root of 5, and the area is 1 plus square root of 5 times 2 times 1 plus square root of 5. There we go. Okay, and our final example outside of geometry comes from physics. And in physics, we see quadratic equations pop up when we talk about projectile motion. Okay, so motion under gravity is another way to think about it. So here, right, we have a formula, and this one you might have to look up, but the height of an object experiencing only gravity on it is given by, and we have to be in certain units, feet and seconds, right? Gives gives the equation negative 16 t squared plus VO times t is the formula we're going to use. So here in the example, we have a man throwing a ball into the air with a velocity of 96. So VO represents the initial velocity. To determine when the ball will reach a height of 48 feet. Okay, so I have my equation. H is equal to negative 16 t squared plus VOT. Okay, and so now I'm going to substitute what I know in. H is 48, negative 16 t squared plus 96, right? This is VO, and then times t. Rearrange, set it equals 0, negative 16 t squared plus 96t minus 48. Okay, now all of this, I can divide the whole thing by both sides of the equation by negative 16. Okay, happens to be a GCF, so 0 is equal to t squared minus 6t and then plus 3. Okay, and now this one, it doesn't factor cleanly, so let's try the quadratic formula. So t is equal to negative of a negative 6 plus or minus square root, negative 6 quantity squared minus 4 times 1 times 3 all over 2 times 1. 6 plus or minus square root 36 minus 12 all over 2. Okay. 6 plus or minus square root 24 over 2, and 24 breaks down 4 times 6, so then I think I end up with 6 plus or minus 2 square root of 6, square root of 4 is 2, all over 2, and so then this simplifies to 3 plus or minus square root of 6. Okay, and actually either one of these, if you do the math, will work. So I would say the ball reaches 48 feet high, high at t equals 3 plus square root of 6 and 3 minus square root of 6 seconds. Okay, and you could round these depending. This one it didn't say to do so, but you could round these as well if you needed to. Okay, this was a longer video. Hopefully, it's helpful to go through some of these models and know that quadratic equations actually have a use.